Good night, PEP scholars. Welcome back to another live PEP class, and we're going to be doing some more curriculum-based test sample questions, brand new, fresh, out of the oven. Before we go into that, though, here's our schedule of live classes. Hello CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the error beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand. All right, and okay, so welcome to everyone who is joining us in studio and out there in the universe. Chrissy K is reminding me that Chrissy K says, Miss, remember that you did not do part 2 of the PEP ability test paper 2022. I remember, Chrissy K. Thank you for reminding me, but I do remember. But what happened is, well, remember when we started part 1, there were a lot of glitches. We had internet problems. And so I think I'm going to need to do over part 1. Also, I need to get the quality of the paper that I was using, the quality of the pics. I'm sure you can remember they weren't that good. So what I might do is just see if I can get some better quality material, and then we'll do over that paper. But I do have it in mind. We are going to be doing it over, right? So let me welcome those who are backstage. Jaden was here very early. Welcome, Jaden. And also,
good night, Miss. Good evening, Miss.
Hi, Jaden. We have John and Amari. I love your shirt, Jaden. I love that color.
Good night, thanks, Miss.
Good night, Miss and classmates. Love classmates.
Good night, John. Good night, Amari. Okay, so it's time now to share the screen. And that's our new sessions, curriculum-based test prepared and presented by me. All right, so for the first question, we're going to be looking at these. We're going to use these 3 figures for question 1. So the black figure is a square. The blue figure is a square and the red figure is a rectangle. All right, so you can jot down the dimensions if you want. Although we're gonna come back to it still. So Jaden, I'm gonna ask you to read question 1.
Okay, miss. Number 1A. How many, should I read all of this or just 1A?
Yeah. Read all of it twice and then we'll go through it piece by piece.
Okay, miss. Number 1A. How many of the black squares can fit into the rectangle? B. How many of the blue squares can fit into the rectangle? C. If I have a piece of string that can go around the blue square exactly twice, how many string would I need to go around the rectangle 3 times? D. If I place 2 boxes within the rectangle, if I place 2 blue boxes within the rectangle, how many of the black box would then fit? 1A. How many of the black squares can fit into the rectangle? B. How many of the blue squares can fit into the rectangle? C. How many of no. B. How many of the blue squares can fit into the rectangle? C. If I have a piece of string that can go around the blue square twice, how much more string would I need to go around the red rectangle 3 times? And D. If I place 2 blue boxes within the rectangle, how many of the black box would fit in then? Could in then fit?
All right, so let's take 1A first. How many of the black squares can fit into the rectangle? And the rectangle is the red. So the black square, how many of the black squares can fit into the rectangle? Let me hear your answers. And of course, there are more than one ways that we can work this out. So when you tell me your answer, I would appreciate it if you tell me your method.
Miss, could I read? Miss, for 1A,
Yes,
it says how many black squares can
Miss
fit
John.
into the rectangle? Miss, the area for the box. Oh wait, miss for this black square, miss. That's 1, miss. On the area for the red rectangle, miss, that's 54. So miss, 54 black squares can fit into the rectangle.
Okay, how did you
Yes,
get
I
the
also
54?
agree with that. Because I just multiplied 9 and 6, because if there's one black square is 1 centimeter, it can effectively would be the area of the rectangle. Would that be the amount of the black squares in the rectangle?
Okay. All right, so John, that's correct, and Jaden is correct. So we work out the area of the black square and divide it into the area of the red rectangle. 1 times 1, of course, is 1 meter square, and 9 times 6, 54 meters square. And 54 divided by 1 is 54. So, all right. How about, okay, so let's write that. So that's 54 of the black squares. And the method was, we found the area of the black square, which is 1 times 1 meter square. Area of the rectangle, 9 times 6 meters square, and we divide the area of the Rectangle by the area of the square. How about B? How many of the blue squares can fit into the rectangle? Who wants to take this one? How many of the blue squares can fit
Miss
into the
18.
rectangle? Tell me how you got 18.
Miss, I divided 54 by 3.
You divided 54 by 3.
Yes, miss.
3. Why 3? Why did you choose 3?
I'm rethinking it, but I chose 3 because it's the length. It's the
All
width.
right. That's incorrect. Does anyone know why that answer is incorrect?
Miss, is it because that's just the length and not the actual perimeter?
Do we need the perimeter? What did we do for the first one? Right, so Chrissy K is saying we should divide by 9, not 3. We should find the area of the blue square, which will be 3 times 3. And that's what we did for the black square, remember? It was 1 times 1. That's how we got the 1. It seems like we're using the same number, but it's not. The length of the black square was 1 meter. The area was 1 meter square. So we need now to find the area of the blue square, which is 3 times 9, 3 times 3, sorry, which is 9 meters square. And that's what we're dividing into the 56 meters square, which is, do I have my units right? Let me check something. Oh, it's centimeters. Why do I say meters? It's centimeters, right? So for this one, it would be 6. 56 divided by 9, 56 centimeters squared divided by 9 centimeters squared, that's 6. All right, how about C? If I have a piece of string that can go around the blue square exactly twice, how much more string would I need to go around the rectangle 3 times? If I have a piece of string that can go around the blue square exactly twice, how much more string would I need to go around the red rectangle 3 times? How about that one? So let me go back to the shapes. How much more string would I need to be able to go around the rectangle 3 times? Any thoughts on this one? Anyone want to walk us through? So I have a piece of string.
Miss, would find the Miss would we Miss, what I was would it be like finding the perimeter of the red rectangle and then
Which is
you could be
which is what?
the parent is the perimeter is 30 and then
The
tripling that
perimeter. Hmm.
and then tripling that to meet the 3 times because it's going
Mm-hmm.
around it 3 times.
All right.
So that
So
would
how
be
much is that?
90.
Okay. What next? Welcome, Jer. All right, so Jaden
Oh,
is saying
nice.
we'll find the perimeter of the red rectangle and multiply it by 3 because we're going to need to go around it 3 times. And he said he got 90 for that. So what's the next step, Jaden? And when we say how much more string, we mean in terms of centimeters. How many centimeters of string?
Miss, would we do the same thing we did for the red? So basically, we would find the perimeter of the blue square, which is 12. Double that
Mm-hmm.
because it's going around with 2 times 24 and take away 24 from 90.
And you'd get what?
Which,
So Shamar
which,
is asking which number we're at. We're still at number 1.
which you would get 66.
What's the unit?
66 centimeters. Miss.
All right, that is correct, Jaden. So 66 centimeters. So Jaden is saying first we find the perimeter of the rectangle. So the length is 9 centimeters, the width is 6 centimeters. So 2 times the length plus 2 times the width. The perimeter of the red rectangle is 30 centimeters. And since we're going around it 3 times, that would be 30 times 3, which is 90 centimeters. For the blue square, we had enough string to go around it twice. So the perimeter is 3 times 4, which is 12. And if we're going around it twice, it's 12 times 2. So that's 24 centimeters. So we would subtract the 24 centimeters from the 90 centimeters to see how much more string we would need. And that is 66 centimeters. For D, if I place 2 blue boxes within the rectangle, how many of the black box could I then fit? If I place 2 blue boxes inside a rectangle, how many of the black boxes would I then be able to fit? Let me hear your thoughts, your thoughts on this one.
This, I'm not sure. I'm not very sure about this one, but is it 6?
Let me hear your reasoning, Jaden.
Because no, miss, this I was thinking that this, if it was 3 times 3, which would be 6, that would be one side of the rectangle. One side of the rectangle, the left side. Was that one reason? Because I'm not sure about. What just happened? Am I the only one here?
Yeah, I think so, miss. I think miss has internet problems again.
What?
I think miss has internet problems.
Students, let me know if you can hear me, please.
Miss, I can hear you.
Yes, miss.
Yes, I can hear you too.
What?
All right. So there was a power outage. Um, over where I am, there was a power outage. So we're going to continue with the stream. Okay. All right. So let me share the screen again. And we were at D, right? We were at D. All right. So so Jaden, was it you who was explaining D?
Miss, I said I would rethink it,
Have you
but
rethought?
then
Have you rethought it?
not yet, miss. After the whole power outage, it kind of went.
All right. So does anyone else want to try for D? If I place two of the blue boxes, the blue squares inside a rectangle, how many of the black box could I put? Hi Madison, welcome. Anybody wants to try for D? John, Amari, Shalicia, Jer.
Miss, if I place two blue boxes within there. Miss, how many? Oh no, the blue boxes was 27.
Hi Madison.
No. Miss,
Yes.
it would be Miss. It would be 6 times. Miss six. Miss, I'll say 6.
What makes you say six, John?
Okay. Miss.
Hold on. Jaden, hold on a bit, please. Go ahead, John.
Okay. Miss the tangle, Miss. It'd be 9 times 6, which is 54 centimeter squared.
Mm-hmm.
And the
Okay.
area of the blue box is 3 times 3, which is 9, Miss. So 9 divided, 54 divided by 9, Miss. You
No,
get
but
6. Yes,
John,
Miss. Yes, Miss.
you're putting two of the blue boxes.
Oh, yes, Miss. Okay, so Miss, it'd be 27.
So how would you get 27?
Miss, because Miss will. Oh, don't worry, Miss. I mean, Miss, it will be 18. Miss would add the area of the two blue boxes.
And
Yes.
that would tell me how many of the black boxes I can fit.
Miss, it says if you put Miss, it's. Oh, wait. There's two. Okay.
Madison, speak. Oh, Shalicia's mic isn't working either. So those, if your mic isn't working, just type your answer. So listen, we already know the area of the rectangle is 9 times 6, which is 54 centimeters square. If we're putting two blue boxes in, and we know the area of one blue box is 3 times 3, which is 9. So two of them would take up 9 times 2, 18 centimeters square. If we subtract that 18 centimeters square from the 54 centimeters square of the rectangular area, we'll be left with an area of 36 centimeters square. And we divide that by the area of the black box, which we know is 1 centimeter square. So 36 boxes can hold, right? So Rodriguez, did you say 30 or 36? I'm seeing two answers from you. The answer, however, is 36. So here are the steps. Area of, so that's 36 boxes. Area of the rectangle, we already worked that out. Length times width, which is 9 times 6. And area of the blue square is 3 times 3, and it's two of them, so that's 9 times 2 is 18. So we have to take that out of the 54, right? Take that out of the 54, because remember now, if this is the rectangle, we're fitting two of the blue boxes. So we have to subtract that area out of the total area. So whatever is left back would be the area that the black boxes are gonna fill. And since each black box is 1 centimeter square, we divide that into the 36 centimeters square that's left. So John, can you read question 2, please?
Okay, miss. Number 2. Share $480 among Lisa, Joey, and Sharon so that Lisa gets twice as much as Joey, and Sharon gets
Joe.
5 times as much as Joey.
Joe.
Number 2. Oh, sorry, Miss Joe. I keep on saying Joey. Number 2. Share $480 among Lisa, Joe, and Sharon so that Lisa gets twice as much as Joe, and Sharon gets 5 times as much as Joe. Oh, Miss, wait for them in narration. So, Miss, there should be 5 to 2 to 1.
Okay. How you come by that, John?
That's how I come out. Miss. Miss, because there's 3 persons there. Okay, Miss, I put it in the ratio form because it'd be easier to work it out.
How you come by these numbers, I'm
Oh,
asking.
Miss, because it says Sharon gets 5 times as much as Joe. Lisa gets twice as much as Joe, Miss. So, Miss, Joe, the 1.
Okay, so you're using the 1, the unit ratio, to represent Joe. And Sharon gets Lisa. So this is Lisa. Lisa gets twice as much as Joe. And so Sharon would get 5 times as much as Joe. All right, so how much money does each of these persons get then? So for Joe, let's work out Joe's money.
Okay, Miss, it would be okay. So Miss will add up all the ratios. Miss, then we'll get 3. Sorry, 8. Miss will get 8.
So
So
1
Miss,
plus 2 plus 5, that gives 8.
yes, Miss.
Uh-huh. And then for Joe,
Okay, Miss Joe would be 3. No, Miss 104.8 times $480.
and 8 into 480 goes,
Miss 60 times.
and 1 times 60.
Miss at 60.
Okay, so Joe gets $60. And for Lisa,
Miss Lisa would be 2/8 times $480.
all right, so 8 into that, 60. 2 times 60. 2 times
Miss 2
60.
times 60 is 120. Miss.
All right, so Lisa gets 120. And for Sharon,
Miss for Sharon. Miss would be 5/8 times 480. Miss. And 18 to 480, that's 60 times. And 5 times 60, that's $300, miss.
All right, so Sharon gets $200. Do these figures add up? Because they should add up, right? So we should be
Yes,
able
miss.
to add, if we add the $300 plus the
Miss
120
it works out. Miss it works out.
plus the 60, we'll get back the $480.
Yes, miss it works
Okay,
out.
so very good, John. So this was a good idea to express it in terms of ratio. So since Joe gets the least, we use 1 to represent the unit value of the ratio, that's Joe. And we are told that Lisa gets twice as much as Joe. So if 1 is representing Joe, then 2 would represent Lisa. She got twice as much. And Sharon got 5 times as much as Joe. So Joe is 1, Sharon must be 5. And then we add the unit values to get the sum of the ratio. Put each value over the sum times the total amount of money, and we work out how much each person gets. Amari, please read question 3.
Miss, can you hear me?
I can hear you.
Okay, miss. Question 3. The, the whole number the whole numbers less than 20 are written in cards, placed in a bag and shaken. Placed in a bag and shaken. A number is chosen randomly each time and replaced. What is the probability of choosing? A. Whole number. A. Whole number. B. A prime number. C. A composite number.
So instead of replace, it is returned. So next time you're reading it, Amari, you
Yes,
say returned, okay? Go ahead and read the rest.
okay. And D. An even number. F. An odd number. F. A square number. G. A factor number of 20. A factor of 20. Sorry. 3. The whole number 3. The whole the whole numbers less than 20 are written on cards, placed in a bag and shaken. And now and what is the probability of choosing a whole number, B a prime number, C a composite number, D an even number, E an odd number, F a square number, G a factor.
All right, so first of all, let's list the whole numbers less than 20. What's the first one?
Miss,
What's the
can you please
first?
Miss, can you please repeat the question?
So I'm saying they want us to consider the whole numbers less than 20. So I'm saying let's list them.
Okay, miss.
What are the whole numbers less than 20? What's the first one? What's the first whole number?
Miss one.
One is not the first whole number.
Miss, 0 is the first whole number.
Zero is zero.
So 0 is the first whole number. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Should 20 be in it?
No, miss.
Why not?
Miss, because it says numbers less than 20, miss.
So only those that are less than 20.
Yes, miss.
20 is not in it. 20 is not less than 20. It's equal to 20. So the whole numbers less than 20 are from 0 all the way up to 19. So we're putting all these numbers on cards, each one on a card, putting it in a bag, shaking them up, dipping our hand into the bag and choosing one at random. When we choose that one, each time we return it to the bag. So the number of numbers is always the same. We're not taking out any and putting it aside. So what's the probability of choosing a whole number? What is the probability of choosing a whole number? Who wants to have a go at that one? What's the probability of choosing a whole number? If we put those numbers in the bag and pick one, okay, so I'm seeing Rodriguez is saying 0 over 19. Madison says 19 out of 19. That is correct. There are 19 whole numbers and there are 19 numbers in the bag. So that's 19 out of 19, which is 1. So the probability is 1. We are sure, we're certain to choose a whole number because that's all we put in there were whole numbers, right? So it's sure. When something is certain, the probability is 1. What's the probability of choosing a prime number? Who wants to define for me?
A prime number? Yes, miss, I would like to.
Go ahead.
Miss, a prime number is a number that has less than 3 factors, miss. Miss,
Not just less than 3, exactly 2 factors.
yes, miss. 2 factors, miss. Miss, itself and 1.
Okay. So how many numbers up here are prime?
Okay, miss. Okay. One,
What's the
two,
first prime number? What's the first prime number?
miss 1.
No.
Oh, sorry, miss 2, 2, 2. Miss
2
2.
is the first prime number. Okay.
Yes, miss. And then it's 3. Then it's 5. Then it's 7. Then it's 9. Then it's 11. Then it's 13. And then it's miss 17. And then 19.
So how many of them? So we have 1, 2, 3, 4, 5, 6, 7, 8 prime numbers. So the probability of choosing it would be 8 out of 19.
Yes, miss.
What's the probability of choosing a composite number? What's a composite number? Who knows what a composite number is? Let me give you a hint. A composite number could be considered as the opposite of a prime number, with only a few exceptions. Only a few exceptions. If it's not prime, it's composite. So what would a composite number be?
Miss,
Go
Miss,
ahead,
a composite.
Felicia.
Yes, Miss.
What's a composite number?
Miss, a composite number is a number that has two or more factors.
That's correct. And Alexia also said that a number that has more than two factors. So it can go into itself, one can go into it, and at least one other number can go into it. So what are the composite numbers from the list that we have here? The first composite number then would be what? What would be the first composite number? The first number up here that has three or more numbers that can go into it. Anybody?
Miss, two.
No, 2 is prime. Remember we said 2 is prime? Shelly says saying Alexia is her middle name. That's great. So we have Alexia Paisley in the chat. Alexia, Shelly says saying you're her namesake. So if a composite number is a number that three or more numbers can divide evenly into it, the first composite number would be 4. 4 can go into itself, 1 can go into 4, and 2 can go into 4. So 4 is the first composite number, and then the next one would be 6, then 8,
Then
then 9,
eight.
10, then 12, then 14, 15, 16, 18. So let's see how many of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of choosing a composite number would be 10 out of the 19. And what's the probability of choosing an even number? So even numbers start at 2 and they go up by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18.
Miss, it's 9 out of 19.
So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's correct. There are 9 even numbers out of the 19. And the odd numbers start at 1. So that's 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. How many odd numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 odd numbers. What's the probability of having a square number? Who wants to define a square number?
Miss, I
What's
would
a,
like to define a square number.
go ahead, John.
Miss, a square number is a number that when you multiply it by itself. Miss, the square numbers are 1.
When you multiply a number by itself,
Yes, Miss, you get it.
you get a square number. So the first square number is, what's the first square number? Are you hearing me, guys?
Yes, Miss, the square number, Miss,
The
1.
first square number is 1,
Yes,
right?
Miss. Miss, and the second is 4. Then
So
it's 9,
1, 4,
9.
9, and
Miss, 25, but that's not. Wait.
no, 16 would
Oh,
be
yes.
then.
Yes, Miss, I forgot.
Okay. So there are 4 square numbers in this batch: 1, 4, 9, and 16. So the probability of selecting a square number then would be 4 out of the 19. And what's the probability of selecting a factor of 20? What are the factors of 20 there? What are the numbers that can go into 20?
Miss 1,
1,
2, 4, 6, 10.
4, not 6, 5.
Oh, Miss, sorry, 5. 5,
Mhm.
10. 6.
So it's 1, 2,
Wait, what?
4, 5, and 10. How many numbers that?
Miss, that
1,
is.
2, 3, 4. 5 numbers.
Yes, Miss, 5.
5
5
factors
out
of
of 19.
in this batch. Okay.
Yes.
So the probability is 5 out of 19. Well, this question isn't there, but what's the probability? What's the probability of getting a multiple of 20?
Okay, Miss, I'm multiple. Miss, there's not really a possibility, Miss.
So what would be the probability in terms of numerical value?
Miss, 0 to 19.
Right, so it would be 0. 0 over 19 or 0. There's no chance of getting a multiple of 20 because the numbers do not include even the first multiple of 20, which is 20. So the probability would be 0. So when an event is not likely to happen at all, the probability is 0. All right, Madison, can you read question 4, please? And this will be our last question. Is your mic working, Madison? Okay, JR, is your mic working?
Yes, miss.
Can you read question 4, please?
4. A cart can hold a maximum weight of 1.2 kilograms. Which three items can you place into the cart without exceeding the maximum weight?
Which one?
Number 4. A cart can hold a maximum weight of 1.2 kilograms. Which three items can you place into the cart without exceeding the maximum weight?
All right. So the cart has a maximum weight that you can put in it. So which three items? We have a sack of yams, we have a sack of flour, a sack of oranges, a sack of potatoes, and a sack of rice. Which three are we able to carry and still stay within the allowed weight for the cart? This is the last question, guys. So you should be shooting your answers out of every orifice.
Miss, could I go?
Sure.
Okay, Miss, 1,000 grams make a kilogram.
Yes.
Um,
So 1,000 grams
make a kilogram.
is the
Miss,
same
we
as
could put the rice.
1 kilogram. So the 1.2 kilogram would be how many grams?
Miss, it be 100. Miss, 1,200 grams.
So if we multiply the 1.2 kilogram times 1,000, we get how much?
Miss, Miss, I could. Miss, with. Oh, yes.
We
Okay.
get 1,000. So we need to see which of these three, when we add them up, they don't pass 1,200
Yes.
grams. So which three is saying, John?
Miss, I was working. Miss, I was just adding it, Miss, but it wasn't going to work out. Miss, because I'd have two twos.
All right. Anybody else want to try?
Okay. 450.
Which
530.
3 items can we put? So that it doesn't pass the 1,200 grams. Remember, it's 3 of those things. You can put the yam, the flour, the orange, or the flour, the orange, the rice, or the rice, the flour, the potato. You tell me which 3. Which 3 will stay under the 1,200 when we add them up.
Oh. Okay, miss.
Can we do some rounding off?
Oh, yeah, miss. Yes, miss.
Do
We can
some
round
quick
it up.
rounding off in your head now and see.
Miss,
Ah.
if rounding off is allowed, would it be yams, flour, and oranges?
So I'm saying rounding off just so that we'll narrow it down, but we still have to add it up. So you're saying the oranges, which is 450.
Miss, when you add up all of them, it would give you 1,180.
That sound less than 1,002, doesn't it?
Yes, miss.
So if we add, we add in the oranges, the flour, and the yams, and we get, and this is in grams, 9 and 9, 18, 1,180. So these are the 3 items. These are the 3 items. If we add the rice and the orange, that gone over, that's nearly 1,000 already. So anything else would carry it over, right? So basically, the potatoes and the rice are out because they are 500 and something, and there's no way you can add 2 other things and stay within the range. So these are the 3. All right, so even though we encountered some glitches again tonight. Hi, Ajani. We encountered some difficulties again tonight. We still pressed on. And thank you guys for staying with me. Even though there was such a delay, the electricity went and took us a little while to come back. Thanks for sticking around. Join me again tomorrow. We're going to do more curriculum-based tests. All right, so I'll see you guys tomorrow. Thank you, scholars, as always, those in the chat. Thanks for participating, posting your answers, your questions, and so on. I'll see you tomorrow.
Bye. See you tonight in the secret. Bye, secret class, miss. Bye, mates.
Bye, miss. Tomorrow.
Bye, guys. All right, so
Bye, miss.
all right, so I'm going to play the schedule of classes as usual. Hello, CSET Math students. busy preparing for your math tests and your CSEC exams coming up, I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.